Okay, so we're going to discuss validity. And validity in this case, and basically in all cases, what we're talking about with validity is it valid? And valid means truthful, valid means correct. And what we're really talking about here when we're looking at test validity is, does the test truly measure what we're claiming it measures? In other words, if we claim a test as a measure of general cognitive ability, is it valid to make that claim? Can we support that claim with evidence and data? So we're going to be talking about validity from that viewpoint of the concept of, are we actually measuring what we're thinking we're measuring? And I've mentioned in class before that validity is kind of the gold standard in test development in most of the social sciences and definitely in science in general. So from the science practitioner viewpoint, validity is a very important component of that science component. And I'm not trying to discount its value. But I am wanting to again kind of mention that it's probably a little less important to us from a purely data-driven decision-making viewpoint of a lot of organizational decision makers, that we're trying to provide them with measures of individual differences that actually predict performance. We can use it to predict whether someone should be promoted, someone should be trained, or whether someone should be hired. And within that framework of the utility of the tool, it is a little less important that it's measuring exactly what we're claiming it measures, as long as it has a strong relationship with the actual outcome we're interested in predicting. So in social science, we don't want to claim that we're measuring authoritarianism unless we really have a great definition and we know what we mean by authoritarianism, what is it, and then that we can show that the test truly does measure it on multiple dimensions. That's test validation, trying to prove not only that the test predicts what it should predict, but also that it truly is a measure of the psychological construct that we claim we're actually measuring. In the case of industrial organizational psychology, though this is still important, the bottom line is a little bit more, yeah, but does it predict what we want it to predict? So just kind of keep that in mind as we're talking about validity. So validity by definition is the extent to which one can draw appropriate inferences from a test score. And again, that's a pared down definition that I use in this class and industrial organizational classes that's leaving a little bit of that construct reality, that construct validity out, and mainly focusing on, can we draw appropriate inferences from a test score? So the test score is what the actual test is producing. It may be irregardless of whether that test is truly valid to a construct. And can we draw inferences from that test score on how well someone is going to perform on an organizationally relevant outcome? And that's really what we're more focused on in most validity validations that we do in industrial organizational psychology. Speaking of my own experiences, I don't remember ever being asked by a large company, can you prove that we are measuring the construct that we think we're measuring? In other words, I've never been actually contracted to truly show construct validity. No one has ever said, we have a measure of managerial skill style. Can you prove to us that we're truly getting the conceptual measure of what it means to have that managerial style in this test? No, I'm hired to bring in, can you find out if this test that we're using, and they're not even asking whether it's measuring what they think it's measuring, but can you find out this test that we're using, is there data to suggest that it predicts what we want it to predict? So we validate the inferences, not the test. We're not necessarily validating saying this test is valid. What we're validating is whether the inferences we draw from this test truly relate to constructs that we'd expect this test to be related to. So the validation is on our assumption. The test itself, reliability is going to tell us how well that test is working. Classical test theory is going to tell us how well those items are working. It's going to give us some information about just the function of the test. Is it differentiating? And then we have whatever we're wanting to predict, whether that is organizational outcomes such as sales, whether that's production, whether that's quality, whether that's number of absentees, whatever it is that we're wanting this test to predict. Both of those are constructs. The test is measuring a construct, some individual difference in people, and our outcome is some form of measurement of a construct, of performance, or subcategory of performance. Our validation is focused on the inferences that we can draw from one construct to the other, from the personnel test to the actual performance. So typically valid tests by their very nature are reliable, and this is a little bit of a lie in that you could have a valid test that's unreliable. Remember, reliability just means that you're seeing very little error in the test. You have very little error that's coming in from other sources. It's truly measuring something accurately. But one of the assumptions of almost all personality tests, almost all tests of individual difference in people, is that what we're measuring, the constructs, are stable. So if you're extroverted, you're assumed to be extroverted in most situations. If you have general cognitive ability, you're assumed to have that general cognitive ability at approximately the same level in all situations. Now, they may change slowly over time, where we're not expecting great changes in personality difference variables. The one situation you could have a valid test that's not reliable would be if you're actually measuring something that's highly variable. Now, if you'll remember from our lectures on performance, performance is fairly dynamic. And that's kind of one of the problems we have when we talk about the difference between the personality test, personal differences test, which I've been mentioning, we have an enormous amount of research on, and our measures of performance, where there's a lot less research going on. Well, one of the reasons for that is that performance seems to be not necessarily a super reliable, constant measure in a lot of different people. Some, but not all. So again, broadly speaking, when we move forward, we assume that a valid test is reliable under the assumption that what we're measuring is a reliable, stable trait that someone would have. But it should be noted that reliable tests may not always be valid. So you can have a hyper-reliable test that's not measuring what you think it's measuring. Now, in the social sciences, this is a major problem because we're creating these tests to infer the measurement of a construct. We're trying to get at some definable individual difference that we think is research worthy. This is still a bit of an issue in organizational settings, but a little bit less as long as that reliable, quote-unquote non-valid test does predict what we want it to predict. Now, generally, we're not going to be much in that situation because part of creating a valid test in organizational settings is to find out, does it predict what we'd expect it to predict? So if we had a test that we thought was measuring some personality related to performance, and we found out it does predict performance, that in itself would start to suggest the test is at least semi-valid. That what we're measuring in the person at least is something close to what we think it is because it is affecting performance. Another thing to just note is that tests are valid for some purposes but not others. So all tests have limitations of when they're actually measuring the construct successfully, and no test is perfect. So there's a bunch of different cognitive ability tests out there because each one tends to focus on, they all claim if they're a general cognitive ability test that they are a general test of that ability, but all of them have some skew to whether they're mainly focused on nonverbal reasoning, more focused on verbal reasoning, more focused on mathematical reasoning. And each one of those tests then would be a better predictor, more valid in its inferences, in its ability to predict, depending what the job actually was called, what the job required of the person, whether it was more mathematical ability, verbal ability, non-spatial reasoning ability, etc. So there's two broad categories of how to look at validity. There's the tripartite model and the Unitarian model. Now, both of them use the same methodology. So the tripartite model is the older one. It's kind of the gold standard. It was actually created by Conan and Campbell, I believe, in 1955. That's not a direct quote. I don't have that in front of me. But basically, people that are doing a lot of other research in scale validation, in how we look at reliability, also proposed this model of how to measure validity. And they basically said there's three types of validity, or three ways to examine validity within your study. The Unitarian model basically says validation should be a hypothesis testing model, and that hypothesis testing model should not be broken down into subcategories. It should use all of the methods to come up to one clear conclusion. Either you are able to infer that you're capturing the construct you're interested in. This measure is a measure of general cognitive ability. This measure is a measure of authoritarianism. Or you can't. And that the way you should think about it is not whether you have one of the three types or two of the three types, but all of these are basically hypothesis testing. And every time we test a hypothesis, we have the null hypothesis, we're wrong. And the alternative hypothesis, we actually are right. And in this case, what the Unitarian model says is that validation is really about validating the construct. It should be focused on the construct. So this is more of a theory of science, of how it should be done. And that unless everything you do converges on that hypothesis, that alternative hypothesis, that you do have construct validity, then you shouldn't claim validity. While the tripartite model basically breaks the three methods up and say there's three different ways to look at validity depending on what you're interested in. So those three methods is content-related validity, criterion-related validity, and construct-related evidence or validity. So content-related, we're going to talk about each one of these briefly in turn. Content basically says, do you have enough items, do you have enough questions that actually get at the construct totally? So if I was trying to make an argument that I'm measuring performance in a job, let's say specifically in a secretarial worker, and the only thing I'm measuring is their typing speed, I don't have a lot of content-related evidence at that point. Because unless the only thing that person does is typing, there's a lot of elements of performance that I missed. So if my claim is that this is a measure of all secretarial performance, I would fail on the content-related evidence. However, if I was saying I am measuring purely the construct of typing speed and accuracy, and the test measured how many words can you type in a minute and how many mistakes you can make, I've got content-related evidence then for that particular construct, typing ability. Criterion-related evidence is basically is whatever you're measuring predicting what you'd expect it to measure. In other words, you're starting with the inference. General cognitive ability should relate to performance on a test, especially if that test is an educational test or a test of measuring knowledge or ability. Therefore, I look, are they related? Is my measure of general cognitive ability related to test performance in other areas? If it is, that's criterion-related evidence. So this is the one that focuses on that prediction. And finally, construct-related evidence is usually more complex methodologies of basically looking for convergent and divergent evidence. So convergent evidence, it associates with what you expect it to associate. It differentiates between groups you'd expect it to differentiate. And divergent is it doesn't relate to things it shouldn't be related to. It doesn't predict group differences that it wouldn't predict. So a quick example of that might be if you're looking in a clinical setting and you have a group of people that you know have been previously diagnosed with schizophrenia and you have a new measure of schizophrenia. Well, you'd expect it to predict people that you know have schizophrenia as yeses and people that you know do not suffer from schizophrenia as nos. That would be convergent validity. Divergent validity would mean that if it also predicts whether or not you're a male or a female, or whether it predicts or not whether you're going to do well in spatial perception tests, well, there's not evidence in the past that basically schizophrenia is necessarily related to either of those. There is gender differences in how schizophrenia actually exhibits behaviors, but not necessarily in the actual diagnoses. So that would be divergent validity if you found that there wasn't those relationships, because you wouldn't expect them. So we're going to talk about content validity first, the part of test development, and really the question here is, does the test appropriately sample the content of the job? And it's somewhat based on judgment rather than statistics. So we can put some numbers to this process, and we've already kind of hit on the idea of this, that whenever we're creating a measure of something that we're interested in, personality difference, one of the first things we often want to do is create basically a question bank. We want to create a cloud of all the possible questions we could ask. And we kind of talked about this also when we're creating a measure of performance based on a job analysis. We want to use that job analysis to tell us what are all the questions that we need to ask to truly capture performance. That's content validation. We're trying to basically brainstorm out a database, a list of all possible questions. And that list may be much larger than the final test because we may find that many questions kind of lump together, and we want to make sure that the test is also manageable. Now, some of this is judgment. Obviously, when you're creating these items for this test, creating the content, a lot of it's going to be based on the individuals making it. One of the ways that we can try to reduce bias here is involve as many people as possible in the creation of this initial group of questions. So a lot of times you'll want to get together a lot, if it's, for example, again, performance off of a job analysis, You probably want a couple of external consultants that wrote the job analysis. You probably want people that actually manage the people that do the job. You also want people that are doing the job, and maybe even people that interact with those, whether they're customers or subordinates or direct reports. And then have all of them generate this bank, if you will, of all these items. Then systematically what you want to do is go through and have additional experts or subject matter experts that have the job, incumbents, to go through and rate how much they agree each item really is capturing the construct that's currently being measured. And you can then use those statistics, descriptive statistics, to kind of weed down the number of items into a manageable measure. Another part of content validity is purely face validity. So once you actually have your list of items, does it actually look valid to the people who are going to take the test? Does it look like a measure of performance for that particular job? Does it look like a measure of extroversion? Does it look like a measure of authoritarianism? So most of these constructs that we're usually trying to measure to predict in businesses and in the social sciences are somewhat culturally constructed concepts. They're definitions that have been defined by our language, our experiences, and also somewhat in what we see in other people. So the idea of extroversion in one country may vary from what extroversion means in another country based on how the behaviors that are involved and how it actually shows itself. So in a very conservative, reserved country or culture, lesser behaviors might still be seen as extremely extroverted, while those same behaviors in a very independently minded and kind of open culture might actually be seen as almost introverted by comparison. So there's a fair amount of cultural definition going on in any construct that we're using to define differences in individuals. So a part of that is to go back to that culture and go, does this look like what we're expecting when we talk about this construct, extroversion, authoritarianism, or performance? So some tests obviously have very high face validity and some have low. The advantages of face validity is the first thing is that if you have a test that does not have high face validity, it may be very effective, it may be very predictive, but if someone takes it and at the end of taking it they go, I have no idea what they were measuring, and now that they've measured it, I have no idea how this relates to my job. If that person then finds out they didn't get the job or they didn't get the promotion because they did poorly on that test, how do you think they're going to react? So there is a reality to using tests in organizations that we do want to think about what is being communicated by that test and how are people buying in or accepting that test. So the more face valid it is, usually the more acceptance there is. Again, if you took this test and it clearly was a measure of your managerial skills, all the items were about management, all of them were about management style, you may disagree that your style isn't necessarily the one the company's looking for, but if they tell you, well, we were looking for someone really focused on group behaviors and working interactively in a social environment with their employees, and your score said that you're a very directive leader that's focused on tasks, if it had high face validity, you'd go, well, I disagree with what you were looking for, but I do agree, yes, I'm a task-focused leader, and that's what that test measured. Generally speaking, low face validity tests are often tests that have been what we call criterion-related developed. And what that means is that basically you just brainstorm any items. You actively try not to get high face validity items. You can come up with just random weird questions. The MMTI is a good example of this. You're being asked questions about whether you liked a particular fiction. You're asked whether you want to, drink a scotch on the porch or play frisbee. And honestly, a lot of these items, you may not be able to figure out exactly what they're measuring. And in fact, the people who created these items might not even know what they're measuring. What they then did is they compared them to criterion. They basically criterion-ally keyed them to known group differences. So once they have all these low face validity questions, they give them out to thousands of people that they know are already in various groups, such as high performers, low performers. If it's a clinical diagnosis, someone diagnosed with schizophrenia, someone isn't. And if they find that a large number of people that are schizophrenic say that they want to drink scotch, and a very low number of people that aren't schizophrenic say they want to drink scotch, that item may now become a predictor, amongst many other items, of that diagnosis. Now that would have very low face validity, so it's hard to cheat on the test. It's hard to answer in ways that are going to get you the results you want. But the other problem with that, again, is it's also going to probably be rejected if it's being used to make decisions in the organization. Like almost everything in the measurement and dealing with people, there's always positives and minuses. There's never a perfect solution. High face validity, people are going to accept the scores better. Downside, it's going to be easier for them to cheat or to exaggerate their responses to hopefully get the result they're looking for. Low face validity, harder to cheat, more likely to get honest answers, harder to develop because you do have to go through a lot of validation processes with known populations before you can actually key what the results of those tests infer. But with that low face validity, people are probably going to be pretty resentful when that test keeps them from getting hired or promoted. So content validation steps in organizational psychology, we always start with the job analysis, whether to tell us what needs to be used as a predictor or to indicate what we need to measure for performance. The test development panel is what we're going to start with, and that test development process is actually creating the test and creating that initial content, so generating all those items. We're then going to have an SME review, subject matter experts, or content evaluation panel, and they're basically going to be asked whether or not something is essential, whether it's useful but not essential, and whether it's unnecessary. So every subject matter expert is going to go through every item and rate it as one of these three categories. And then we're going to create a critical value for each one of those actual items based on the following equation, where NE is the number of subject matter experts rating it as essential. So this is small n. So if you had, for example, 50 people evaluating something, you would take the number that actually rated as essential. So let's say if there's 50 of them, let's say 40 of them rated as essential, 10 did not. We're then going to subtract the total number of subject matter experts, in this case 50, divided by 2, divided by, again, the total number of SMEs, 50 divided by 2. Generally, a rule of thumb is that if you have a CVR of an individual item of less than 0.80, that's probably an item that you want to consider not using. Now, that is a rule of thumb. It's not a hard line, because sometimes what we're trying to measure is a very difficult thing to measure, and there's not a lot of agreement on what items need to be used. And in that case, we might find that none of our items pass this 0.80 test. It's just a good rule of thumb to think of that if you've got a bunch of items and you're trying to get down from 200 items to 20 or 30, one of the first tests you might want to do is just calculate the CVRs and take any item with a value of 0.80 and then take a look to see what's left. Again, this doesn't make it a statistical test, but it does take personal judgments of the subject matter experts and create a more systematic way of choosing which items are making the cut. So criterion-related validity is literally using correlations and regressions to calculate a validity coefficient. It's the correlation between the predictor, the test that we're actually trying to validate, and some form of criterion. In organizational settings, almost always job performance. We're generally looking for it to be statistically significant and an R of at least 0.30 or higher. So again, we're not expecting these tests to be enormous predictors of performance, but if we're claiming you should use this test to help you make performance decisions, we want to make sure there's at least a moderate relationship going on there. Now, to do a criterion-related validation, generally we need an adequate statistical power, and that generally means at least 100 people for a validation test if we're using criterion-related validity. Now again, correlations and regressions have generally a minimum of 10 per variable. So if all we're looking at is this predictor test by criterion, our stats knowledge would tell us we need 20 people or more. But 20 people or more is not a strong, powerful test. And quite honestly, if we're running one of these, we really want to be sure, if we're going to use it for decision, that we had enough people in there to be fairly confident in what we found. And that's why I would suggest a rule of, instead of 10 per variable, closer to 50 per variable. We do want to make sure that we have the appropriate criterion. In other words, if we have a poor measure of job performance, it's going to be hard to criterion relate the validity to anything that we're trying to predict with. There's two types of criterion-related validity, and both have their advantages and disadvantages, and that's predictive and concurrent. And I'm going to talk about each one of these in turn as well. But concurrent validity basically means it's happening at the exact same time. I'm giving people a predictor test, and I'm measuring the outcome at the same time. Predictive means I have a time lag. I'm giving people the predictor test, and then once they've taken that test, I'm actually waiting to find out what their performance is. So concurrent takes less time. However, it should be noted that motivation does affect predictor scores. So if someone's doing a concurrent study, you're probably not actually hiring or firing or promoting them, because you are basically measuring their performance and their outcome at the same time, which means they may be a little bit less motivated. They may also be more motivated if for some reason they're really motivated to do well on the test, but not necessarily motivated to do well on performance. Now, what generally happens with a concurrent validity test is we're actually measuring people that are already in the organization. That's how we can do concurrent validity. So we're not having to wait to get their performance because we already have it. So it's a pre-existing value at this point. So concurrent can basically mean two different things. The first thing it can mean is that we actually measure our predictor and our outcome at the same time, or we were measuring our predictor when we already have access to the person's outcome. So in this case, because in organizations when we do concurrent validity, I have a brand new selection tool, I want to validate it before we ever use it for decision making, so I grab 100 employees of the company that I already have performance data on, and I give them the test. That's where this motivation and job experience comes in. Motivation can now affect those predictor scores. So those 100 people I'm giving the test to, they're not motivated to do their very best. They're not trying to get promoted. They're not trying to get hired. They're already hired. So they're probably going to be a little less motivated to do well on that test compared to real people taking it if we actually use it for selection or promotion. The next thing is that we're also now testing a predictor, a new test that we're expecting to use on people that have never had the job or are right at the point of being promoted, and we're giving it to people that are veterans of the job. So again, that job experience can affect the predictor score. So these are some of the limitations. Correlation coefficients are similar for cognitive ability tests, and what that means is that generally speaking, when we're giving concurrent validity, we're basically doing a concurrent validity study. What we often find as far as the interrelationship between the people taking that test and the test, so how reliable the test is for it, it's fairly similar to cognitive ability tests, which is fairly good, but that's also a bit of a disadvantage, because that also means that we're measuring people that are fairly stable in their jobs. So it's kind of a sign that the fact that we find, no matter what the test is, fairly decent reliability coefficients generally is indicating that this is not the best way to do this. The advantage here is it's cheap and it's easy. We're not having to risk making decisions before we know whether something works or not. We can validate with pre-existing people that are in the organization, and all we have to do is give them the new test we're trying to validate, because hopefully we already have their performance data. Now, it should be noted whenever we do a validation study in this manner, so whenever we're doing actual predictive validity, we do need to work at notice the fact of what we call validity shrinkage or cross-validation. So generally what we find is the validity of a selection battery will always be highest for the sample on which it was validated. Other samples will tend to be lower. And what this kind of gets at is that whenever we're actually validating, we're really focused on trying to make sure we've reduced error, that we're doing the best we can at that test administration, that we're doing the best we can to get the right people into the study. So we as experimenters are trying to create an ideal situation to test our test, which means that when we get the validation information, in other words, the correlation between our test and what we're trying to infer and predict with it, it's probably going to be at a higher level than how that tool will be used in the real world, where people may be taking it in different situations at different times and kind of honestly just like more sloppily. So we do want to cross-validate. We want to apply that same predictor and criterion to a different sample. What this often will look like for cross-validation is once we've actually validated using concurrent validity, we may actually do, the first time we start using this now to actually predict or basically use it for hiring or use it for promotion, that at that point we want to double check the data and see, okay, how is this now working in the real world? One of the ways we can actually estimate this is to cross-validate. So we calculate the predicted scores from the regression equation from that first validation. So again, the first time we run a validation, we're going to actually get the regression equation. We're going to get the prediction. So then we give people the actual test that we're going to use for decision making. And what we want to now calculate is correlate what their predicted score was with the actual criterion score for the second sample. So let me walk through this quickly. So what that means is that we started with a concurrent validity study. We carefully selected people that were already in the organization. We had them take the predictive battery. And then, based on that predictive battery, we compared it to their known performance data. From that, we got a regression equation. Now, that regression equation is based on that sample. That's what we're going to use to now predict future people's scores. Now, we bring people in to actually interview in the company. We give them that test. We get their scores. Now, we don't have their performance data yet, but with their scores, we run the regression equation from the first sample to predict their scores. And in this case, we actually do it. We add a variable in our SPSS or Excel file of the prediction. Now we sit back and wait for the predictive information to roll in. We've hired these people. We've predicted what their performance is going to be. After a set period of time, 6 weeks, 2 months, we get our first set of performance evaluations. We put that in, and then we look to see how correlated is their actual performance, not with their test scores, but with the prediction from their test scores. Then we compare those two effect sizes. We compare the R-square of the value of the prediction from the first sample with this cross-validation. The smaller the difference between those two R-squares, and remember R-square is prediction. So the first R-square we're looking at is the actual effect size of our first sample, the people that were in the organization that we had performance data in. The R-square or effect size from the second that we're looking at is the effect size of the relationship between the prediction and the actual performance. Those two R-squares are going to be different, and generally that second one, the validity shrinkage one, is going to be smaller. The smaller the difference, though, the better. So we want those two R-squares to be as close to each other as possible. So construct validity is the most important type of validity, especially from a scientific model. Construct is a trait or characteristic, and it basically is being used to explain organizational and behavioral consistencies within an organization. Does a test measure the construct that it's supposed to measure? That's the question construct validity is asking it. Construct validity is not asking, does it look like it measures what it's measuring? That's content validity. Construct validity is not asking whether or not it measures what we expected, or does it predict what we expected to measure. That's, again, that second type of validity. Construct validity is a summation of all three and an extension of those. So the steps in construct validation, again, we want to start with a job analysis. But in this time, we're not looking at specific items of the job analysis. We're asking what psychological constructs are relevant to the most individual components of job performance in this job. We then want to identify or create a test of that specific construct. So notice that in the past, I've been talking about using a job analysis to generate actual items of performance. In this case, we're looking at a cluster of items on the job analysis and saying, all of these seem to be strongly related to cognitive ability, or these three items seem to be related to spatial perception abilities. Once we have those constructs, we now look for tests that would measure that construct. We then want to gather evidence that the test measures that construct. So for example, we can look at nomological networks. Basically, these are studies that look at the interrelationship amongst the constructs and their measures. We can look at convergent validity, and we can look at divergent validity. So let me break these down really quickly. Nomological networks are usually going to be for either a complex study where you're examining everything all at once. You're literally looking at the convergent, divergent validity in a cluster of studies. Or you're drawing on past research, past nomological network studies that have gathered this evidence for you, that this really is a measure of the construct that you're interested in. So for example, if what you come out of the job analysis is we need a measure of general cognitive ability, you may not actually run individual studies yourself. You may fall back on meta-analyses and massive construct validations of whatever measure you choose. If you're actually going to gather the data yourself, you're usually going to use a combination of convergent validity and divergent or discriminant validity. So convergent validity simply means that whatever the test is highly correlated with tests that measure similar or same things. And divergent validity means low correlations with tests that measure different things. So usually how we're looking at both of those together, so this is an example of a model that we could use to measure convergent and divergent validation at the same time. This is called a multi-trait, multi-method matrix. And it's fairly common. And the basic concept here is that you have traits and methods. And the traits are going to be 3 different traits, and usually the methods are going to be 3 different methods. Now obviously you can get more complex. You could have 4 traits, you could have 4 methods, you could have 4 traits and 3 methods, you could have 2 methods and 6 traits. But the idea is that you have traits that measure the same thing, similar things, dissimilar things. And then you have multiple methods of measuring them. So for example, methods in this case is, for example, a pen and paper test versus an in-person interview versus an interactive online test. So those are 3 different methods. Now we'd expect that there to be some correlation between methods regardless of what you're measuring. So for example, a pen and paper test, whether you're taking a pen or paper test on Napoleonic history, advanced physics, or knowledge of a drill press, if you have a general cognitive ability that predicts your ability to take multiple choice tests, you're probably going to do a little better on all of those tests, regardless of whether you know anything about the subjects, than someone that's not good at taking tests. So we'd actually expect 2 pen and paper tests of the very different concepts to possibly have some relation to each other. However, we wouldn't necessarily expect there to be a strong correlation between your ability to perform on a written test and your ability to perform on an in-person interview. Those would be less likely to be related, regardless of the subject. And then we'd expect that measures of the same thing, but different types of measures, so example, again, a measure of extroversion that's a pen and paper test, a measure of extroversion that's an in-person interview, or a measure of extroversion that's an interactive computer test, all of those should be relatively highly correlated. However, a computer test of extroversion versus a computer test of introversion should not necessarily be as strongly correlated. So what we're actually doing is we're giving a large group of people multiple tests using multiple methods and then putting them into one matrix. And this is the matrix that we would get in that case. So in this case, the top, going along the top, we have traits A, B, and C, and we have methods 1, 2, and 3. So trait A, for example, might be drill press operation. Drill press operation trait A1 is drill press operation from a pen and paper test. A2 is drill press operation gathered from an interview, and method 3 would be A3, drill press operation based on an interactive computer test. Along the bottom then is additionally other traits with the same methods. So the methods stay the same, the constructs are measured, but these are different measures of the same concept. So at that point what we're looking at is, again, we've got that same drill press operation and that same method. So again, what we're going to look at then is what we're interested in. For example, if we look at method 1, trait A1 at the top, as we go down A1, we're first going to look at how well did it relate to other measures. So A1 again was pen and paper. If we walk down that vertical column, what we're going to find is that A1 relates to A2, drill press operation, as measured by an interview, at a correlation of 0.57. Drill press measurement, pen and paper versus computer adaptive is A3 down that column, and it's related at 0.56. So these green diagonals are our validity diagonals. The green diagonals are showing us the same constructs being measured by 3 different methods. And what we're wanting to see here is that we want to see those actual numbers to be the highest. So when we're looking at a multi-trait, multi-method matrix to make an argument of construct validity, the first thing we're looking at is the diagonals that represent the same trait measured by different methods. We should see the highest correlations in these diagonals. Now, the red diagonals in this chart are when we have a similar method of measurement but different constructs. In this case, these should be lower than the green diagonals. So the red triangles are what happens. This is measuring test normality. So heterotrait, different traits, monomethod triangles. Monomethod, same method. So for example, if we look at that very bottom right rectangle, we're going to see that A3 is a measure at drill press operation. However, it's related at 0.67 to B3, so a pen and paper test of a completely different construct. Likewise, that measure of drill press operation, pen and paper test, is related to C, which is again a completely different construct, fairly highly as well. We don't necessarily expect these numbers to be non-significant or small, but we hope to see that they're smaller than the actual green, the validity diagonals. Same test, same construct, different method. In this case, the red triangles are not showing us what we want to see at this point, because what we actually see is in some cases we're actually seeing stronger correlations by the method than the traits. And finally, we have the orange triangles. These are heterotrait, heteromethod triangles. These are where we're not only are we not measuring the same construct, or at least we don't think we're measuring the same construct, we're also not even using the same method. And these should be the lowest that we see. Now this is a pretty complex way to try to get at construct validity, and I use this because this is honestly one of the most easy ways to make a strong argument for construct validation. Notice that I have convergent validity, same methods, or same measures using the same methods. I have that convergent validity of same constructs being measured with different methods, i.e. different scales. I also have divergent validity, comparing the construct I'm interested in to constructs I'm not interested in. That's one of the reasons these nomological networks can become quite complex, and we don't often do them honestly in organizational psychology. We'll usually actually turn towards pre-existing summaries or pre-existing studies for that. However, we can, in isolation, simply go, well, this new measure we created, we expect it to be predicting drill press operation. So we're going to give it to people. We're then going to measure their performance in drill press. We'll go ahead and also look at their lateness, and we'll also look at just kind of general social ratings they get from their managers. We wouldn't actually expect there to be a strong relationship with our predictor of drill press operation with whether or not they show up for work and whether or not they're social to their coworkers. So those last two would be divergent validity. We expect low numbers there. And the first one, actual performance of the drill press, would be convergent validity.